Okay, friends, today is an exciting day because we are starting factoring. So you'll notice that your paper, I believe, says Factoring 101. When you go to college and you take English 101 or Math 101, it is the basic college English, basic college level math. So today we're doing the beginnings of factoring. Very exciting. So we're going to take out the greatest common factor. You might remember greatest common factor, just real quickly talking about this. I call this an aside anytime I go off on a tangent, but sometimes it's a good tangent. If I was like, hey, find the greatest common factor between 12 and 18, okay? Well, you would probably do this. This is how you were taught to do it. 6 times 2, circle the 2 because it's prime. 3 times 2, circle the 2 and circle the 3 because it's prime. And then you would do this one as well. You'd say, okay, well, 6 times 3, circle the 3 because it's prime. And then that's going to be 3 times 2, circle them because they're prime. And then you'd say, okay, well, what do we got in common? Well, we have this 3 in common with this 3. So it's 3. We have this 2 in common with this 2. So it's times 2. And these guys are not in common, so your common factor, your greatest common factor is 6. I don't know. To simplify it, what number goes into both of those numbers? What number divides into 12 evenly and divides into 18 evenly? Well, 6 is that number. So today that understanding is going to be very important. And this factoring thing, you're going to be doing this for a long time. You're going to be doing this for the rest of this school year probably in Algebra 1. And then you are going to do it a lot in Algebra 2 as well in a couple years. So don't blink. This is an important one. So this is kind of a note to me for the most part, but we're going to be taking out the greatest common factor. That's our big thing today. And I don't think we're going to do too much more than that. We might do a little bit of the basics. But, okay, I'm talking too much. We got to get some work done. All right, so factoring 101. So I want you to think about this as the opposite of multiplying or distributing. So if I was like, hey, I want you to do the distributive property backwards on something, right? Well, I think you would say, okay, you know this, right? You know that these 3 things multiply to these 3 things. Please write that out. Please write that out because I don't think you have that. You see how those ribbons work. I want to do that same thing in reverse. So I'm saying, hey, if this is the end result, what could distribute here? Okay, so tell me what number goes into 2x and 2. Is there a number that goes into both of those? Yeah, 2 goes into both. So 2 is your GCF. Your GCF is 2. And now if you take 2 and you multiply it by x, you get 2x. Look at that red ribbon. The first red ribbon gives you 2x, which is this. And then 2 times 1 will give you this, right? These are check marks, sorry. That looks like a Nike one. Just do it. Kind of pretty good one. So we're doing the distributive property backwards, okay? It's called factoring. It's called factoring out a greatest common factor, and it is going to be your life. I mean, you're going to eat, breathe, sleep this stuff, okay? So I hope you're excited as I am. I'm pretty pumped. This is one of my stronger sections. I have a lot of pretty cool activities for this. As long as we have time, we gotta make it happen. And I really like teaching it. It's a lot of fun. So should be a good thing. Should rub off, okay? So we're trying to take something out of this. What number goes into 3 and into 6? Well, 3 goes in. 3 divides into 3, and 3 divides into 6. So I'm going to take a 3 out. Now remember, we're trying to do the distributive property backwards, so let's put our parentheses like that. Now here's the next thing, okay? Variables. We got to deal with those as well. Of course we can deal with the numbers, not a big deal. Also, kind of just a quick side note, the GCF is the greatest common factor. The CF is the common factor. You can't just take out a number that goes into everything. You have to take out the biggest number that goes into everything. And in this case, it's just the 3. We got to look at the variables, though, now. Okay, so sorry about that. Here's the deal. Can both of these x squared and x, can they both afford to lose one x? Can they both give away an x? Yes, I would say yes. They both have an x to give, right? The question then becomes, do both of those underlined blue things, can they both give up two x's? Can they both give up an x squared? Can they both give that? Well, this guy here, he's going to run out. This guy at the end, he's going to run out of x's, so he can't give any more. So you just take one x out. You take out whatever the least number of x's is. So just take out just x, straight up x. Now think about distributive property. 3x times what? Well, we know 3 times 1 is going to give us that 3x squared, right? 3x, but we don't have another, we need x times x, so that would make sense. So just look at the green ribbon and see if the green ribbon, in your opinion, does the green ribbon give you the green underline? That's the big test, okay? I'm going slow because this is a big topic. We can't mess around with this. Does the green ribbon give you the green underline? I would say yes. We're going to do another ribbon. I guess it's, I don't know. I'm kind of low on colors here, people. I really hate to use yellow. I guess I'm just going to have to use black. Sorry about that. Okay, so 3 times positive 2 will give me positive 6. And 3x times positive 2 will give me positive 6x. Does the black ribbon give you the black underline? That's the question. If the answer is yes, you are done factoring. For now. I mean, eventually it gets harder. Okay, so I'm going to try to pick up the pace a little bit. I went through that one in pretty good detail. You can always distribute, by the way, if you see the bottom there. If you distribute your answer, right, you can get the original problem, hopefully. What goes into 14, 7, and 21? The number that goes in is 7. Are there variables? Can everybody give away an x? No. This guy could give away 3. He's rich, okay? This guy could give away 2. But 21 has no x's to give. He cannot give away an x, so we cannot take an x out. So 7 times 2, x to the third. 7 times, how am I going to get this? Well, that's going to be 7 times 1, x squared. And then how am I going to get this? I'm going to have negative 3. 7 times negative 3. So the big test is, does this distribute back out? Okay? So I want you to go ahead and distribute that. You don't usually have to do this. This is a check. So the check is, go ahead and do it. Pause the video. Try it. Okay. The check is that this comes out to 14x to the third plus 7x squared when we're distributing the red minus 21. Funny thing is that is that. So you have factored that correctly. Okay? That's how you do it. All right, let's move on. You're going to do some practice. This is a big, big topic. We cannot mess around. So there's tons of practice here. I'm just going to go down, scroll. Factor out the GCF from the following expressions. We're not doing great on time, so I guess I'm just going to slow it down, and then I'm going to break this into 2 videos. So that's the way life is going to be today. So let's look at this right now. So what goes into this and into this? I'm going to say 2. 2 will go into 10, and 2 will go into 8. So this is equal to 2 times 5 is 10. 2 times 4 is 8. This should distribute to this. Hopefully you are understanding. I'm going to go fast through the first couple. Okay, here's a big question that people have to ask a lot. Usually, when there is a negative in front, see how there's a negative 12 there, and down on number 11 there's a negative 4? Usually when there's a negative in front, we take a negative out. So I'm going to take out a negative. I think 3 is going to go into both of those numbers. 3 divides into 12, and 3 divides into 21. Can they both lose an n? No. So it's going to be 4n minus 7. Negative 3 times negative 7. This should distribute out to this. We're doing the distributive property. in reverse. Okay, what number goes into 14 and into 7? 7 divides into 14 and into 7. Do they both have x's to give? Yes. They can both give up 1x. Can they both give up 2x's? No. The first guy, 14x, he only has 1x to give, so you can only take 1x out. So I'm going to take out an x, only an x, and then I'm going to have whatever is happening. So this 7x times 2 will give me 14x, that's that. And then 7x times just plain old positive x, that'll give me 7x squared. That's done. You don't have to distribute every time to get your answer. Let me go through the next two kind of quicker. 10, 5, and 25. They all divide by 5. They don't all have n's to give up, so we can only take out a 5. So 10 divided by 5 is 2. There's no n's coming out. Negative 5 divided by 5 is negative 1. Or if you multiply, you're going to have to multiply by negative 1. 5 times 5 is 25, and that's the answer. Looking at the next one. 15, 15, 20. They all divide by 5. Do they all have a k to give? Yes. Do they all have 2k to give? At least. Yes. Do they all have 3k? Can they both give out k to the third? Yes. Can they all give out 4k's, k to the fourth? Yes. Can they all give out 5k's, k to the fifth? No. That's where it ends. They can take out k to the fourth then. So if you just look for the lowest exponent, that's pretty much what you're going to be using. And now we have to think about what this is. Well, he gave away 4k, so he's got no k's left, and it's 5 times 3 to get 15. There are no k's here because he gave them all out. If you multiply that, you get 15k to the fourth, which is this. Okay, 5 times 3 is 15k, but we need a k to the fifth. We have k to the fourth. We took 4 out. We have 1 left inside. Now we have 5. Okay, so that's good. And then we have 5 times 4 to get 20. We have 4k's on the outside. We need to have k to the sixth. We took 2 away, so there are 2. Sorry, we took 4 away, so there are 2 left. Okay. And on to our last example. Then you're going to try all of the evens, okay? I want that to be very clear that you are trying all of the evens. Do not forget. Okay, and I will do this last problem. 4. They can all divide by 4, right? Here's where it gets weird. They could all divide by 2, right? 2 goes into 4, 2 divides into 20, 2 divides into 16. It's all good, but it has to be the highest number that divides in. And 4 is the highest number. When you have a negative in the front, you take it out. That's an ideal way to do it. Can they all give up a p? Yes, they all have a p in them, right there, 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 and there. Can they all give up p squared, 2 p's? Do they all have that to give? No, they can't. So you can only take 1 p out. And now I'm going to just go through this. I might be going a little fast. How are we doing on time? Not bad. Negative times a negative 5 would be a positive. We had 3 p's. We took 1 out, so it's p to the second. Negative 4 times negative 4 will give me positive 16. We had 5 p's. We took 1 out, so now we have 4 p's left. And that is our answer factored. The GCF is factored out. Take your time going through these problems. They are very important. Very important. And make sure you're taking out the greatest common factor. Pay attention to the numbers first, the coefficients. Take that number out and then pay attention to the variables. Do it in 2 steps. Take your time. Any questions that you have, please ask in class. I will talk to you soon. It's been a pleasure.